A ballistic pendulum. So a ballistic pendulum is one where you have a block of wood hanging on a string that is completely immobile, it's at rest, and then you have a bullet that is shot towards the block that embeds itself into the block and moves the block. And the block eventually moves in like a pendulum motion. You guys know what a pendulum is, right?
Of course.
What is it?
똑딱 똑딱.
Oh, is that really what it's called? Like, 똑딱? Right. Okay.
It goes back and forth.
Right, a pendulum is one that goes back and forth. You'll see those in grandfather clocks with the little like swing of the motion.
Yes.
And so the reason why ballistic pendulums are considered a perfectly inelastic collision is because initially what happens is that they combine together. The projectile, the bullet, and the block combines together, which is the definition of an inelastic collision, and the momentum is conserved. And some of the kinetic energy is lost in that connection between the block and the projectile. However, because it moves in a pendulum motion, you can also say that the mechanical energy is conserved in this object, in this swing. And so using the max height of the swing, you can use that to find the kinetic energy of the block, which can then help you use conservation of momentum equation to find the initial speed of the projectile. I said a lot there. Let me show you what that means. So the momentum is conserved, meaning the momentum of the mass of the projectile should equal...
MB?
Yes.
B? What is B?
B is block.
Block.
B is block, P is projectile.
Okay.
So when momentum is conserved, this is how the equation is going to look. Well, if you do this though, but because the velocity of the block is 0, we can cancel that out as 0. And when we rearrange the equation to equal the velocity of the block, you get mp over... You get this equation right there. Another thing you know is that the total mechanical energy is conserved in the system. And so that equation looks like this. With this being the kinetic energy and this being the potential energy being conserved. And because you have the same variable, VB here, to rearrange that, you're going to get that VB equals the square root of 2GH. And so when you equal these equations together, when you combine them together, you get that 2GH, square root of that, equals... And then to find the projectile, you rearrange that equation to be that one up there. The mass of the projectile plus the mass of the block times 2GH. That's where you get that equation. You got it? Or you finally understand what we're actually learning. You get this?